Hi, this is another one of the videos from the Unit 1 module assessment for Algebra 2B. This assessment covered 3 different standards. This is one of the 3 standards. It's FBF5. That standard talks about understanding the inverse relationship between exponents and logarithms, and then use this to solve problems involving logarithms and exponents. So here's the basics behind logarithms and exponents. So we have some number is equal to b to the x, but we don't know what x is. And so that's when logs come in handy, where the base is always b. It's all about that base. It stays down because if you think about the bass with music, it's the lower notes that kind of keeps the rhythm going. And it's the same thing with math. It's the lower one that keeps things going. It's kind of sets the tone. So this B is really important, this base right there. And also another thing that you can do to help remember what goes where is remember that the X, that's supposed to mean E exponent, is right there. And this always equals the exponent. Another way that I remember how to do these things and what it means and how to remember everything is it goes like this. You can go B to the X is equal to A. So notice it made that little loop-de thing. And if we wanted to write it in log form, we would do log base, so log base B of A is equal to X. So they kind of make circles that go one way or other, just as a way of remembering how to do it. So if we had that, so everything else is just examples. If we had that f of x was equal to 9 to the x, and we want to know what is the inverse of that, well, how we're supposed to find inverses, if you remember, is we're supposed to switch the x and the y. So we're going to make this the y and make that the x. So it'd be x is equal to 9 to the y. And then we're supposed to solve for y. So y is in the exponent. That's good. So remember, it needs to equal that exponent. We're going to do the method that we just did. So b base that of this equals that. So log base 9 of x is equal to y. And then once we do that for these, then you make that y, replace y with f of x, f negative 1 of x. So it is f negative 1 of x is equal to log base 9 of x. That's it. Write an equation that is equivalent to that thing, to that we have right there. 5 to the r plus 12 equals q. So first thing we want to do is we want to get the stuff that has to the power alone. In other words, I don't want that 12 there. So I'm going to subtract 12 from both sides. So we'll have 5 to the r is equal to q minus 12. And then we're going to do it the same way that we talked about up here, where we have our base to that is equal to that. So we would have log base 5 of q minus 12. Notice I had to put it in parentheses because it's that entire thing on this side is equal to r. Or we could rewrite it, r is equal to log base 5. Notice that when I'm doing my logs, I write a cursive L. That's because if I do like LOG, if I'm not careful, that could look like 109, especially where in other countries the G is written kind of, or the 9 is kind of written like our G's. So, and then Q minus 12. Okay, it's that simple. What is the exponential form of this? And again, you're doing everything right. It's the log, it's doing the other way. So b to the x is equal to a. So it's going to be 7 to the third is equal to 343. So 7 to the third is equal to 343. And in fact, I want to show you. And in fact is 7 to the third is 343. Cool, huh? And then what is the value of log of 1,000? So this is an important thing, small thing, but an important thing. If something just says log, there is an understanding that that base is 10. That's like the basic base for logarithms. So it would say 10 to what power would equal that? It's really quite easy. We just count the zeros like this. There were 1, 2, 3, 4, 5. So that's equal to 5. And that's it. So that is how that question goes. That's how the standard is in the test that you'll be doing. And good luck.